Hey everyone, let's take a look at our Chapter 2 test review. So I have 17 questions here. That's going to cover a good range of everything that is on your test so that you are all good to go. First one, it says the sum of 3 and x is the same as. So the sum of 3 and x, so the sum means to add. The sum of 3 and x is the same as, that's my equals, twice the difference. So twice the difference looks like 2 times the entire difference, which means subtraction of x and 7. So this is what this should look like translated. I'm going to find my answer choice. It looks like it's the last one. Number 2, translate the following equation into a verbal sentence. So far, this starts with 5x minus 8 equals x squared, right? Okay, so 5x. So the sum of 5 and x, no, because sum means add. The second one says the product of 5 and x, so that sounds good. Subtracted by 8, good, is equal to x squared. Oh, that second one looks perfect. But let's check the rest of them. The next one, the product of 5 and x sounds good. Subtracted by 8 sounds good. Is equal to x times 2. X times 2 would look like 2x, so that one's not correct. The last one, the difference of 5 and x subtracted by 8 is equal to x squared. Well, the difference of 5 and x would look like 5 minus x, so that one's no good. Number 3, translate and solve. 6 added by x, so 6 added by x is equal to negative 2. So that's an easy translating. 6 added by x is equal to negative 2. I have numbers on both sides of this equation. I get rid of the number that's on the same side as my variable, which is positive 6. So I'm going to go ahead and subtract 6 on both sides, and we end up getting x equals negative 8. Easy answer. Number 4, 60 is equal to the quotient of x and 6. So 60 is equal to, now quotient means division, the answer to a division problem. So the quotient of x and 6 would look like, x and 5 would look like x divided by 5. Now because x is being divided by 5, the opposite operation is to multiply both sides by 5. So we're going to go ahead and multiply both sides of this equation by 5. That way my 5's on the right are simplified out. I'm left with x equals, and 60 times 5 is 300. Number 5, solve the equation. So in this equation, I have 2/3 x plus 7 equals 1. All right, so first to solve this, do I have numbers on both sides? I absolutely do. I have a 7 and a 1. So my first step is to get rid of the number that's on the same side as my variable. So the way I get rid of a positive 7 is I subtract 7. So then I'm left with 2/3 x equals 1 minus 7 is negative 6. Now, 2/3 and x are side by side, which means to multiply. And what we learned to undo the 2/3 is to multiply both sides by the reciprocal. Reciprocal means you take the fraction, you flip it upside down. So the reciprocal of 2/3 would be 3/2. If I do it to one side of the equation, I have to do it to the other side. This way, you get to cross out your 3's, cross out your 2's. You're left with x equals, and now I do this. Negative 6 times 3 is negative 18. And negative 18 divided by 2 gets me negative 9. So my answer is x equals negative 9. Next one, number 6, solving another equation, another multi-step equation. So here I have negative 42 equals 3 plus 6m. I ask myself, do I have numbers on both sides? I do. I get rid of the number that's on the same side of my equation as my variable, which is this positive 3. So I'm going to go ahead and subtract 3 on both sides. I get negative 45 equals 6m. 6 and m are side by side, which means to multiply. So we go ahead and divide both sides by 6. Now 45 does not divide by 6 perfectly. So I know it's one of those decimal answers, but I could say, hey, 6 goes into 45. Let's see, 6 times 7, right? So 6 goes into 45 7 times, and there's 3 left over, and 3 out of 6 is 0.5, and a negative divided by a positive is a negative. If I use my calculator, I would get the same answer, negative 7.5. All right, number 7, evaluate. So here we're evaluating an absolute value expression. So we have the absolute value of 4 times x, which is negative 5, minus my y, which is 8, close the absolute value bars, plus xy, which is negative 5 times 8. Okay, so the rule is we simplify what's inside the absolute value bars until it gets down to just one number. Then when it's the absolute value of just one number, then we can actually apply the absolute value. So I have to simplify what's in this expression first. So the first thing I'm going to do is 4 times negative 5. So that's the absolute value of negative 20 minus 8, close the absolute value bars. Now plus negative 5 times 8. Well, negative 5 times 8 is negative 40, right? So I don't really want to write plus negative 40. That's really just minus 40. Okay, I still evaluate what's inside my absolute value bars. Negative 20 minus 8 is the absolute value of negative 28 minus 40. Once it's now at this final step of the absolute value of negative 28, I can take the absolute value. The absolute value of negative 28 is just 28, and 28 minus 40 gets me a negative 12. All right, number 8, solving an absolute value equation. So the deal is when we go to solve an absolute value equation, the absolute value expression has to be by itself. And in this case, it is. Like there's nothing on the same side of this equation as my absolute value. It's already isolated by itself. So I don't have to do any special steps. What we do have to think about is, hey, I want 2x plus 9 to either equal positive 11, because the absolute value of 11 is 11, or I want that whole expression 2x plus 9 to equal negative 11, because the absolute value of negative 11 is also 11. So we end up writing two equations. We end up writing 2x plus 9 equals 11, and the second equation we write is 2x plus 9 equals negative 11. Now, when we go to solve, we are going to see we do the same solving steps for both equations. Subtract 9, subtract 9, subtract 9, subtract 9. So here I end up getting 2x equals 2. Over on the right, I end up getting 2x equals negative 20. Then I do the same solving step, divide by 2, divide by 2, divide by 2, divide by 2. I end up getting x equals 1 and x equals negative 10. Okay, so positive 1, negative 10 is my answer. Awesome. Number 9, which ratios form a proportion with 0.25? Select all that apply. All right, so 0.25, if I think about it, right, 25 cents or 25%, 25 out of 100 is really just 1/4. So I know that 1/4 is obviously equal to 0.25, but then I look at the rest of them, right? 3 over 15. Well, if I divide them both by 3, if I simplify this, I end up getting 1/5, so 3/15 is no good. If I look at 4 over 16, well, if I divide both of those by 4, I end up getting 1/4, so that one's good. And then 20 over 80, well, they're both divisible by 20, so if I divide both of those by 20, I also get 1/4. So 3 of those were equal to 1/4. Number 10. So a multi-step equation. So let's take a look at number 10. So number 10 says 2 times x minus 1 plus 6 equals 1 plus 4 times x minus 10. Okay, so the first thing I do is I just start distributing. So I've got 2 times x is 2x. 2 times negative 1 is negative 2. Bring down my plus 6 equals, bring down the 1, distribute the 4. So 4 times x is 4x. 4 times negative 10 is negative 40. Now, before I start adding and subtracting on both sides of this equation, I notice I have numbers on the same side of the equations together. So I really just need to combine like terms. So this becomes 2x plus 4, right? Because negative 2 plus 6 is positive 4. I have to combine my 1 and my negative 40, which is a negative 39. So that's really 4x minus 39. Now, what I should notice is I have numbers on both sides and I have variables on both sides. And when you have both on both sides, you get to really do whatever you want first. So you could subtract 2x on both sides first. You could subtract 4 on both sides. You could subtract 4x on both sides. You could add 39 on both sides, which is actually what I'm going to choose to do. Again, there's 4 different ways to start this equation. So now I have 2x plus 43 equals 4x. At this point, though, after you choose whatever your first step is, you're limited. Like you can only do one thing. So if you did not choose this as the first step, it's okay, but we still should get the exact same final answer. At this point now, I see I have variables on both sides. I have to ask myself, do I get rid of the 2x or the 4x? We never get rid of what's by itself. So think about it. If I got rid of this 4x, I'd have nothing on the right-hand side. You always get rid of the variable that's on the same side as your number. So I'm going to go ahead and subtract 2x on both sides. I then get 43 equals 2x. 2 and x are side by side, so I need to divide, and I end up getting 43 over 2, which is 21.5. Number 11, solve this equation. All right, so I've got 9, and then in parentheses, 2x minus 4, so I've got some more distributing to do. 6 times 3x plus 7. I go ahead, I start distributing, so 9 times 2x is 18x. 9 times negative 4 is negative 36. I distribute on the right-hand side. 6 times 3x is 18x. And then 6 times 7 is positive 42. Another problem where I have numbers on both sides and variables on both sides. So I could start this however I want. I could say, oh, you know what? Let me add 36 on both sides. Okay, plus 36 plus 36. So now I have 18x equals 18x plus 78. Then I would say, oh, I have variables on both sides. Let me go ahead and subtract 18x on both sides. And what we're going to notice in this problem is that your variables are completely gone. And you're going to be left with a mathematical statement that doesn't make any sense. Maybe it's negative 36 equals 42. Maybe it's 0 equals 78. Maybe it's negative 78 equals 0. Okay, and you're going to say to yourself, this doesn't make any sense. When the variables are gone and you're left with a situation that doesn't make any sense, that's when the answer is no solution. However, if I came into a case where I have the same thing on both sides, like 2x plus 5 equals 2x plus 5, and I subtract 2x on both sides, my variables are gone. But look here, I'm left with a true statement like 5 equals 5. Or if I went a step further and subtracted 5 on both sides, I'm left with 0 equals 0. When you're left with that, that's when it's infinitely many solutions or all real numbers, okay? All real numbers is the best answer because all the numbers we know right now in Algebra 1 are real numbers. Any number in the world would work. Number 12, solve for y. So this is rearranging our equations. So we have 5x minus y equals 10. When we want to solve for y, that means we want to get y by itself. So my goal right now is to get this y to be by itself. What I see is that this 5x is on the same side of my equation as that y, so I want to get rid of it. The 5x is positive, so the way we get rid of a positive 5x is to subtract it. So I'm going to do minus 5x minus 5x. I'm left with negative y equals. Now we want to keep the x first, the variable first. So I'm not going to write it as 10 minus 5x. Instead, I'm going to write it as negative 5x plus 10. And now think about it. I want y by itself. It's really negative y. That means that there's a negative 1 in front of my y. So I want to go ahead and last step, divide everything by negative 1, which just means you're changing the signs of everything. So now this becomes y equals. I have to do negative 5x divided by negative 1, which is positive 5x, and then positive 10 divided by negative 1, which is negative 10. Do that looping method for simplifying it, and so I get y equals 5x minus 10. Number 13, percent of change. So percent of change is a very quick formula. Percent of change, okay, it's just difference divided by the original. Like, it seems so silly, but that's really all you do. So a belt that was $12 is now $20. So if I'm talking about, oh, this price went from $12 to $20, what's the difference in that price? How much did it go up by? It went up by $8. So the difference is 8. The original price is always what goes in the denominator. Which one was the original, 12 or 20? It was 12. I go to my calculator. What I'm going to notice is that this is 0.6 repeating. To turn that into a percent, you simply multiply it by 100 or move the decimal 2 spots to the right, which will become 66.6 or 66.7% if I round it, because I see I have actually 67% is what I put my answer choices at. And because the price went up, it's an increase. Now, had the price gone down, it would have been a decrease. So the answer is a 67% increase. All right, number 14, find the final cost. A laptop that was $699 is now 20% off. So first, we have to take the 20%. We have to write it as a decimal. 20% looks like 20 cents, so 0.20. I then take that 0.20 and I multiply it by $699. So I'm going to go to my calculator. I'm going to type in 699 times 0.20. Okay. When I do that, I end up getting $139.80. It says 0.8, but that's really 80 cents. Now that's not the final cost. Notice that is an answer choice. Don't pick that. That's how much we're saving. So now I need to do $6.99 minus the $139.80. So I'm going to do $6.99 minus the $139.80. And when I do that, I get $559.20. Now, that is the two-step method to do this problem. The one-step method would be, hey, if you're saving 20%, then that means 100% minus the 20%, you're really paying 80% of the original price. So the one-step method would be to do $6.99 times 0.80, because that's the percent that you're actually paying. And if I put that in my calculator, you're going to see that you get the exact same answer. So that's the quicker way to definitely do the problem, but you can always do the two-step method. Number 15, you make commission off of every bracelet you sell at a jewelry store. If you make 15% commission, how much money did you make when you sold a bracelet that cost $195? So take 15%. 15% as a decimal looks like 15 cents. So it's 0.15. I take the $195 bracelet. I want to figure out what is 15% of 195. So I do 195 times 0.15. I ended up getting $29.25. Now, because it's commission, it's not tax. I'm not adding that price on. It's not discount. I'm not subtracting it. That is truly just my answer. So it's really just finding 15% of 195. I made $29.25. Number 16, if 8 donuts cost $12, then how much would 28 donuts cost? So this is just a proportion for number 16. So if I set up a proportion of donuts over cost, this would look like 8 donuts over $12 is equal to 28 donuts over how much money? When we solve proportions, we do cross products. So I would do 8 times x, and I would set that equal to 12 times 28. 8 times x is 8x. 12 times 28 is 336. I then go ahead, divide both sides by 8, and I get x equals 42. So that means that 28 donuts would cost $42. Last one. This is our weighted average mixture problem. So it says you are creating a mixture of oranges and bananas for a smoothie shop. If bananas cost 49 cents per pound and oranges cost 89 cents per pound, how many pounds of bananas should be mixed with 5 pounds of oranges so the mixture has an average cost of 60 cents? All right, so I'm going to set up my table. Okay, so in my chart, I'm looking at bananas, oranges, and the mixture. I'm looking at pounds, price, and total. So if bananas cost 49 cents per pound, so I'm going to put 49 cents per pound, and oranges cost 89 cents per pound, how many pounds of bananas, so X goes in for bananas, should be mixed with 5 pounds of oranges so that the mixture price has an average cost of 60 cents per pound? The mixture would be the amount of bananas, X, plus the amount of oranges, 5. The way we fill in the total column is we multiply these straight across. So we do X times 0.49, so that would be 0.49X. We then do 5 times 89 cents per pound. So 5 times 0.89 would give us $4.45. And now if I multiply these across, it's 0.60 times, I'm running out of space, X plus 5. So now what I do for my equation is I'm taking the total cost of bananas, 0.49x, plus the total cost of the oranges, $4.45. That should be equal to the mixture price of 0.60 times x plus 5. So now I'm going to go ahead and start to solve this equation. So I have 0.49x plus $4.45 equals 0.60x. 0.6 times 5 is 3. Okay, I have variables on both sides. Let's say I go ahead and I subtract 0.49x on both sides. So I get 445 equals 0.11x plus 3. I would then say, okay, I have numbers on both sides, so let me go ahead and subtract 3. So now I have 1.45 equals 0.11x. Divide both sides by 0.11. So $1.45 divided by 0.11. I get 13.18, and the 1.8 is repeating. So if I look at my answer choices, it's about 13.2 pounds. I know that was that problem had a lot going on with it, but I hope that was helpful. Good luck on your test. I hope you do well. Bye.